Hello and welcome back, and thank you for joining me on my exploration onto these Max7219 matrix screens. They do fascinate me even, and we've got a long way to go. So today we're just going to do a very basic time code using an ESP8266 chip, a 4-way matrix. We're going to be able to show 24-hour clock, 12-hour clock, and that's it at the moment. But we are going to build onto this code, and we're going to end up having, I think I've got a 12-way matrix which flashes world times and scrolling messages and things like that. So yeah, bear with me, but we've got to learn to walk before we can run. So in the top here, it just tells you what this code is and is going to do and what it's not going to do. So it is very basic, but let me know if you want things added to this code. So as I develop my code here, any input from the comments down below, I can think about adding that end of the code, so it will help you as my subscribers. And thank you for subscribing, by the way. Picked up quite a few. I'm above 200 subscribers now, which is very, very welcoming and rewarding. Not many of you out there from the UK or Italy. Most of you are from the United States. That's why I've included the 12-hour clock for you guys and girls out there. Anyway, let's get on with this code. So the first part here is it's using this library. So you need to make sure you got this library installed, or these libraries installed. And it uses, which if we're using the 8266 chip, it'll use this one. If we're using the ESP32, it will use this one. We need the Parola library because that's the fantastic library that's going to make all the pretty lights flash. Now, I hear you ask, Andy, what's this myconfig.h? Now, further down in the code here, you can see here, I haven't included my Wi-Fi SSID and password just because I'm making these videos, and instead of blurring it out, this is a way around it. So it includes a file. Where are we? It includes a file here, which includes my SSID and password. Now, if you see up here, we've got the code, which we're looking at now. We've got my config, which I'm not going to show you because that's my secret documentation, but I'm going to show you what it looks like in this file. So in here, for you to make this code work, inside the speech marks, put your SSID, and inside the speech marks, put your password. In the code, when it's published, this temp file won't be there. My config file will just be there, but it'll be empty. It'll look exactly the same as this. Just put your details in there and the code will work. Fingers crossed. Okay, so where do we get to? My config. So Parola needs some times and a pause time to make it work, and we'll cover that as we go down the screen. Now, this one, selecting M, or it tells you here if you put an I, you'll get the 24-hour clock or the 12-hour clock. So for my American friends, I haven't left you out. Now, setting up the hardware. I did do a video 45, tells you all about how to set up the 4 different versions of the hardware. And if you're struggling and you're getting some funny dots appear on your screen, you've likely got the wrong code put in here. Video 45 will show you. In this example, I've got a 4-way matrix. That's 8 by 32. So that's why we're using 4. And this is the first time we're using zones. Now, we don't actually need a zone to make this code work, but in later code, we are going to need zones. We're going to need 3 zones in actual fact. And that's just a way of having a long matrix. So you've got a 12-way matrix, and you can say, right, divide that up into 3. Give me 4 matrices on the left, which is zone 1. Say 4 next to that will be zone 2, and the rest will be zone 3. Anyway, it's very clever. Marco wrote these libraries, a very clever man. So these are the pins I'm connecting to on my D1 Mini. I will put a diagram on the screen, show you how to do it. So this is what we just discussed, the SSID and password. It will get it from that file above. Now, time zones. This is the clever part. How can I explain this? This time zone tells the code where you are in the world and when summer and winter time starts. So I'm going to cover this in another video, because this one's going to get long as it is. But I'll cover how you find your zone. I'll show you here. Zones. If you use this link here, just use Control and click. That will take you to this page, and you can see, look, if you're in Africa, you would use this one. So it's telling the software you are. So let's scroll down to Europe. If you're in Rome, like I am, this is the code you need to use. If you're in Paris, this is the code. Now, some of these are going to be the same because Europe is pretty much the same, but find where you are and use that code. So let's crack on. So you need NTP server. So this is where your Wi-Fi chip is going to go and request the time from the internet. Now, they say it's always good to use the closest pool of servers to you to reduce the time lag between your chip requesting it and it sending the time. I'm not sure it makes a lot of difference from what we're doing, and it doesn't go down to the microsecond very well anyway, because the chips aren't that accurate, so I believe. So the way we find them is on this link. So let me now drag this in, because I know what I'm doing. So this will take you to this page, and then if you click here, I'm going to do Europe because that's where we are, and then scroll down here to Italy. There it is. That's the one I use, and it's telling me there's 47 servers available in Italy. I think that's what that's telling me. Or is that number? I don't know. Am I talking rubbish, Andy? So if we go back and do North America, you can scroll down here, see Cuba's got its own. But you need to, well, they say find your nearest time server to where you are and you'll be golden. That's what that one is. And then this one I included just because, drag this in, just because it's easy to look up. You get the abbreviations of where you are, and then it gets the time in front of UTC, etc. So if you're looking and you want to know how many hours in front or behind UTC you are, which is important for the 12-way matrix that I made, because yeah, I did some clever coding on that one. I impressed myself. Anyways, I included that just for reference. So parola is a standard string where it's saying this is the hardware type, and we defined it up. You can see if I run my mouse, it's telling me FC16_HW. The data pin, is 13. The clock pin is 14. CS pin is 15. Max devices is 4. So it's this is the standard information it needs, but we've defined all these at the beginning of the code. So it's good practice to do all your defining and put it at the beginning. So instead of hard coding all that information, in that space there, we could have written FC16_HW, and then we could have written there 13. But you don't want to embed hard code inside your code, because if you want to change something, you then have to scan all the way through your code to find out the little things you need to change. So that's why we're doing it there. So we need to have some variables, some unsigned 16 ints to be able to store the hours and minutes. A string here for allowing us to select metric or imperial for the 24-hour clock. We need to reserve a space to store information in a char array, and that's one thing we need for the matrices to work. So this is for the time, hour output, a minute output, and that will become clear in a minute. So then we are getting, how am I going to describe this? We're getting the time, and then we want to do this fancy bit here. So this is the code that allows us to set this up. And then the way we print the information to the screen is through this line. So we're going to print the information in the char array here, And then this is telling us what information is going to be printed. So here we're doing 2 decimals, and then here we're doing a character, excuse me, and then we're doing 2 more decimals. So the first decimal is the hour, then we're doing this character, and this is going to be the flashing dots in between the hours and the minutes. Then there's a space, and then we're printing the minutes. Anyway, it all comes clear when we use the code. So and then I've included a link here that tells you what the code is asking. You know, the bits you need to put in. We put a C for a character, and where's a D here, or you can use I for the decimal integer. So that's why I included that. Let me close that down. Oh, we're nearly getting to the code. Right, so this is the standard loop. So baud rate, make sure you set that correct. If you, well, there's no real debugging in this code because I took it all out because it made the code really long. So we're going to start Wi-Fi. So this calls a function, and if we scroll down here, it calls this function. So it just starts a Wi-Fi like you may have seen before. It tells you what SSID you're connecting to. It puts in the password here and SSID from above, from that myconfig file. It tells you that it's connecting. Some dots will flash across the screen every half a second while it's trying to connect. And the Wi-Fi address will be published to the serial monitor, and it will tell you your IP address of your chip. So we got up to Wi-Fi, making sure I'm recording. So this function, it sets the environment to whatever you put in the time zone, and we put in the time zone that CET blah 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 blah, which I explained above. So then this is setting up which time servers you want. Now we name them above, so you can see I've got the Italy one. I can't remember, but that was the general one. So there's a fallback. I think you can add more servers than that, but 1 it normally works, 2 is belt and braces. So time format will, depending what we use on the above, we have M for metric or I imperial will dictate what's displayed on the matrix screen, 24-hour, 12-hour. So then we begin parola. Now I didn't explain that, why this is P. So when I set up my instant of parola here, this P, you can call it what you like. So you could say my display or my matrix. Now, whatever you put there, you must then change the P that I have in my code to say if you're going to use my matrix, everything must say my matrix. So you can call that what you want. So I always set inverse to false because I tried to prevent the screen when you plug it in from all the LEDs lighting up red, because in my connections, powering it from the USB, it won't like it. Then I do a clear, and then this is setting up the zone. This is just making the 4 matrices one zone. So that's how we do it. That's the first, that's zone 0 from the 0 screen. So that's the far left to the furthest right. So 0 to 3 equals 4. That's why I got 4 matrices in that. Now intensity, I've made a mistake here, so I'm going to correct that. Intensity goes from 0 to 15. If you're powering it from the USB, I recommend a power setting about 4. These screens are very bright anyway, so 15 will melt your eyeballs. So to get the zone text working, this is saying we want to print something in zone 0. The time is what we want to print, hours and minutes. We're going to have it centered on the screen. This is a speed setting, although we're not using it because we're not doing any movement. We need a time setting. Pause time is 0, and we're just doing a simple print and no effects. Now I did do a video. Did I put it on here? No, I have done a video on effects, and if you will go and watch that, I'll put something on the screen to remind you. You can see all the effects that this software just does somehow. I don't know how it does it. It's all in the library. So then we're going to do a loop. So the first thing we do is go and update the local time. So the time library does this mostly for us, and what it does, it gets the number of seconds since the 1st of January 1970. Now that's a long number, and I'll put an example on the screen as of the 28th of February 2023 at around 1620. And then the software or the libraries then convert this long number into a human readable numbers, and then the strf time function strips out the bits that we want, and then we can print them. So it's doing us all for us, and it's all very clever. So it gets the time from the time servers, and then it makes a local record of the time, and then this was just a reference to show you how this all works. So this is the power of what we're doing by adding all these specifiers, as they call them. We can get all this information printed on the matrix. So we're only going to use this one, the capital H for 24-hour clock, and the capital I for the My American viewers, 12-hour clock, and then capital M just for minutes. So that's why I include that. And we're going to come back to this when we start doing the world clocks. This is going to be important. If we set the time format to metric, it's going to do this, else it's going to read this line down here. So it's going to print the hours in 24-hour clock, and that's going to do that. Else we're going to print the hours in imperial, which is going to say here, it's either 14 if it's 2 o'clock or 02 if it's 12-hour clock. Same thing for the minutes, but minutes are just minutes. And then here I'm changing a char into an integer because I need that back at the top where we're going now. We got to there, didn't we? Right, sorry. Right, so we're back to the beginning of the loop. So we don't like using delays. Delays, as you may know, physically stops your processor from doing anything. It actually stops. Where if you use millis, it's like a counter. You say, right, let's start counting now, and let's say when 1 second has elapsed, and we could have gone around the loop 1,000 times, when you get to this millis statement a little bit further down, if millis equals 1,000, then do something. So rather than saying delay 1,000 and everything grinds to a halt and you can't do anything else, millis is the way forward. So yeah, millis is great. So this is just a bit of code to say when did we come here last time, and this is all to get the flasher, which is the two separating dots between the hours and the minutes flashing. Now if you don't want them, you can just delete this bit of code and it won't do it. So, and this is saying if there's anything in the display ready, go and do that. Now this is the millis routine. So if millis minus last time is greater than 1,000, then do this. Now when it first starts, it won't do that. It's going to go round once because millis is going to equal 0. So it's saying if 0 minus last time, which they're both 0, is greater than 1,000, which they're not, is not going to do that. But then as it's clocking round very, very quickly, the millis will start increasing, and eventually the millis that it's reading at the current time will equal minus last time will be greater or equal than 1,000. Then it will do this. Then it resets it back to 0. The millis will keep counting, but the last time is the last time the millis, this function did something, but then it sets the counter back to 0, and it has to count up back to 1,000 again to do it. So this time, as you see here, last time equals millis. So this, say this equals 1,000 minus last time, so that's 1,000, and when it gets to there, then it sets last time back to 1,000. Anyway, I think you get what I mean. So this is getting the time. It's held hours and the minutes, and it will put the flashing dots in the middle of the display. Then once the display is finished, we reset the display, and it will go back up here, and it will do this. We've done that, so that is the code. So very basic. And now I'm going to well, I can show you here probably. It's back to front and the green screen's got it right. Let me do some recording of that and put it in the screen, because there's one flaw and it really annoys me. And let me talk about it now, because I can insert the video while we're talking. The digits, we're using the standard font that Marco's included in his libraries. Now, a standard font, if we take a letter 4, and you can see on the clock now, it's on the screen, it takes up 1, 2, 3, 4, 5, if I'm counting that right. 1, 2, 3, 5 characters by 7. If we look at the 1, it's 3 columns by 7. So what happens is, I'll insert the clip now. If you've got a 1 in your time, the format all changes, and what it happens is the time will start jumping like this, and it really annoyed me. So in later videos, we'll learn how to make custom characters, and it's not just numbers and letters. You can make, say, you've seen the Space Invaders already. You can make anything that you want. It's really easy, but I make my digits the same width all the time, so the time is correctly formatted and the time will stay static, so it won't jump left and right as the time's clocking up. Anyway, that's it. So yeah, I think the video's dragged on longer than I thought it was going to drag on, but I do like to waffle. But add some comments down below if you get it working. Let me know. If you want to add an addition to the clock, let me know. We are going to add an auto dimming function very shortly after this video. We are going to do custom fonts or custom numerals, and then a later video we'll do how to do the custom fonts. Possibly we'll look at changing the standard library. That might be quite easy. But yeah, quite exciting. So basic project, it's gonna lead us down a long wiggly path. We're gonna learn a lot together. So if you like what I'm doing, I do it for likes and giggles mainly. So add a comment down below, hit the like button if you found it entertaining anyway. And if you should subscribe, I'll be indebted to you, because it makes it all worthwhile. Anyway, that's Andy wishing you a good afternoon. Happy coding as ever.